Before we begin, let's explain a little bit of computer architecture. So, when we run our program, when we run our program is loaded into memory. Then from memory, which is our RAM, is loaded into cache. And cache is a smaller and faster form of memory. Then from cache, it is then loaded into registers before being executed by the CPU. And as you can see, there is a lot of bottleneck from our program getting from one destination to another. And to tackle this overhead, we can just put our program directly in register. So now let's go into details what registers are in C. In C, the register keyword is used as an int to tell the compiler to store a variable directly in the CPU register for faster access. However, modern compilers are smart enough to optimize variable storage themselves. So explicitly using register might not make a noticeable difference in performance. So like if you are using registers explicitly, you might not notice any difference in terms of performance because compilers are smart enough, like these days modern compilers are smart enough to handle variable storage themselves. But let's go over registers. Now in our program, let's say we want to say a variable x, let's say int x. Now let's say x is equal to 20. Now, if we want to store x in a register, we just have to precede x with the keyword register. So we just have to say register. And that's it. We can print our variable. We can do anything we want with our variable. Let's say we want to print. And let's say we want to print out x. If we run it, you should see x is equal to 20. And we can also perform any calculation on x, but the only thing that we cannot do is that we cannot create a pointer pointing to the variable x. So if we try to create a pointer, let's say int y is pointing to the variable x, and if we run this program, you should get a compiler error which is saying that you cannot point to a register variable. So you cannot create a pointer to a register variable, but you can do any other thing you want with a register variable. So I think that sums it up for this video. Thank you for watching.